Okay, so do this first one, 3-hexanol. So oops, 2, 3, 4, 5, 6, and then doesn't really matter which direction I do this from, so I'll just put an OH right there. So then we've got a propanol, 1 propanol and a 3 fluoral. So just 3 carbons. And then I'll put an OH right there. And then I'll put an F right there. If you want me to draw them any other way, let's just say so. I'll do it again. How about the next one? So what's the root for this next one? One, 2, 3, 4, 5, 6. So hex. And what are we going to name it for? An alcohol. So it's a hexanol. What's that 2 telling you? Where the alcohol group is. Okay, and then what else do we have on this? A fluoral on number 1 and a methyl on 5. So 1 fluoro, 5 methyl. Sorry about that. What's wrong with that? What's wrong with saying 5 methyl, 1 fluoro? It's not alphabetical. All right, so I'm going to go with another 2-hexanol, and on this one I've got 1, 2, 3, 4. So 4, 5 dimethyl. Okay with that? What's wrong, Mary?
Just the picture looks weird.
That is weird. Sorry. That better?
Yeah,
The projector evidently isn't high enough resolution. Sad. All right. So 6, 2, 3, 4, 5, 6. 1, 2, 3. We're okay with that? How did I know where to fix the position of the aldehyde? No, it's not that I didn't say so and it's automatically 1. It's always on the end. It's always terminal. It can't be any place else. Okay. Two, 3, 4, 5. If you put an H here, it's not like the worst thing in the world, but it's definitely unnecessary. How about this one? How about that? That? These ones kind of hard to make them hard, right? Because they have to be on an end. How about this 3-octanone? 2, 3, 4, 5, 6, 7, 8. Good with that?
It's basically the same thing as the alpha. It's inside.
The ketones have to be not on an end. So this one is a ketone, and on one side of the ketone I've got 2 carbons, and on the other side of the ketone I've got 3 carbons in an isoform. So I'm gonna draw it like this to make it a little easier to see. So on one side I've got 2 carbons, and on the other side I've got 3 carbons, but I have them hooked up to the middle carbon, not the end carbon, which is why I said iso. We okay with that? That one was probably the most complicated so far. Questions on that one? No?
So when you see the isopropyl, is it just change in orientation?
So what does this part mean? 3 carbon side chain, right? Prop 3 YL side chain. Okay. So if it just said that, then I would have connected this carbon. I would have connected it to this carbon. Are you okay with that? It wouldn't be connected to the middle. But because it says iso, what's that telling you? It means different. It means I'm connecting a side chain 3 carbon differently than on the end. There are 2 options to connect 3 carbons to a chain, either on one of the ends or in the middle. So that's why I have to say iso. Does that make sense? How about this next one? We good with 2-butanone? Can you give me the common name for it? MEK is a super common name for it. Just because we don't usually like things that start with vowels. So if you go to the hardware store, you'll see, or a paint store, you'll definitely see a can that says MEK on it. What's wrong, Ty?
But means they're not in alphabetical order.
I agree with you, but MEK also isn't IUPAC nomenclature, so like all the rules are off.
Focus on IUPAC.
I asked you to name things. If I asked you for IUPAC, then you have to name it IUPAC. If I don't, then I don't really care.
Okay, cool.
So 3 and 4. And so total, it's 8. So 1, 2, 3. So it could be 4 octanone. Or it could be what? You could spell it. We good with that? Which one's the official name? The first one. You have to know the IUPAC one. All right, so pentanamine, 2, 3, 4, 5. You good with that? So 7 carbons. 2, 3, 4, 5, 6, 7. And there's an N attached to it. On carbon 1, 2, 3, 4, there's a chloral. And then on the N, I've got 2 more things. One of them is just a methyl group, and then the other one is a butyl, but connected to position number 2. We good with that? How about naming this one? Does that one make sense? Butane. Does this one make sense? So this is a butane. That's the longest carbon chain. So I'm saying it's 4 carbons and a nitrogen attached to it. So far I've talked about all of that. And then what else is attached to the nitrogen? 1 carbon and 2 carbons. So there's 1 carbon and there's 2 carbons. How did I know they were attached to the nitrogen and not somewhere else on the butane chain? Because I said on the nitrogen and on the nitrogen. Does that make sense? Sorry, misread that. There we go. You okay with that? What's wrong, everyone? So on the nitrogen, there's a 2 carbon chain. So there's my 2 carbon chain attached to my nitrogen. So I've got a
So when you put the two before the ethyl and it's on the second carbon,
I'm sorry? 2?
the idea of the ethyl amine, so the actual amine is on the second carbon, so you put two or
I don't understand what you're asking. No, I want to know.
So your two carbon
Yes.
chain, your base.
Yes.
You put where the bonds are, or is it just bond? That's our first
The double bond, the nitrogen has to be attached to the carbon with the double bond. Has to, or it's not an amide. So that becomes carbon number 1 no matter what. So what's that? Well, what's that functional group right there? That's an amide. So the only way I can have an amide is if I've got a carbon doubly bonded to an oxygen direct, and that carbon's directly bonded to a nitrogen. So that's going to fix position number 1 on my carbon chain. This one? Oh, I see what you're saying. What is this right here? No. Why is that not a carbon? Say again?
The carbon is not the line, it's actually.
This isn't the line structure. This isn't a line structure. How do you know this isn't a line structure? Because I wrote a C. So there are 3 C's, an N, and an O actually written, right? So that means lines are actually what?
Hydrogen.
They're just hydrogens. All right, so 2, 3, 4, 5, 6, 7, 8, 9, 10. You good with that? Two of whatever's next, and in this case, 2 acids. And since they're acids, they have to be on the end. So I don't have to tell you that they're on number 1 and number 10 carbons, because they have to be on carbons number 1 and number 10. Do we see why they have to be? Because this carbon right here, let's look at like this carbon right here. It's bonded on one side to a chain, the oxygen on this side, and then doubly bonded to another oxygen. So I can't have another carbon coming off of it to have a branch. So it's forced to be fixed at the end because I'm ending in an H, which can only have 1 bond. So this one? Good with that? So this one might have been a little confusing because do I name it for the alcohol or do I name it for the acid? I can name an alcohol side chain as hydroxyl. I can't name it an acid side chain as anything other than being an acid. So that kind of ties your hands with that. But the real reasoning behind it is which one of those two things is more reactive, the acid or the alcohol? The acid's more reactive. So that's what I named the molecule for. If there was a double bond on here, I'd have to name it for the double bond and figure out a way to name the acid otherwise.
So why is there for hydroxyl diacid?
There's only one acid.
Because there's not another O.
Yeah, to have an acid, this is the structure for an acid. An oxygen doubly bonded to a carbon, and that carbon has an OH coming off of it. So this carbon only bonded to an OH. Since there's no double bond O, it's an alcohol, not an acid. So this molecule has an alcohol on one side and an acid on the other side. If this was a dioic, then there'd need to be that right there. Butanoate. So 2, 3, 4. So the butane part's easy, it's 4 carbons. What does the O8 mean? It's an ester. So an ester is this structure. Well, actually, that. It's got to have a carbon on the other side of the oxygen. So this butane, right? That's this right here. We okay with that? This O8 is saying on that carbon, I've got a doubly bonded oxygen, and a carbon. So that's telling me it's an ester. This is 3 carbons as a side chain, right? But it's hooked up to the middle carbon instead of the final or the end carbon. So here's 3 carbons hooked up to the middle carbon, not to the end carbon. So we can draw it like this. Are you okay with that? Is that easier to see? What's wrong?
You said it as an
Ester. Yeah.
So are you gonna guess hydroxyl?
Unless I'm specific, unless I say line structure or I say structural diagram or condensed structural diagram, then you can draw it however you'd like to draw it. Two, 3, 4, 5, 6. Are you good with that? What's that piece? That. And then this. The hexane part, right? And then this is 2 carbons that are a side chain. Alright, what do we got here? 2 carbons, 1 carbon. What's this thing right here? An O8. So it's an ester. What's the longest continuous carbon chain? Is that really the way you should ask that? What's the length of the carbon chain that has the double bond O in it? That's actually how you do it. So it's 2. So even if this was like let's say this was 3, I'm still going to name it ethanoate, because the ester part is with the doubly bonded oxygen. Whoa. So there's an example right there. The longer carbon chain is 6, but it doesn't have the C double bond O in it. So then I don't use that as the root name.